Now this brings us to vertical stretches or shrinks and horizontal stretches or shrinks. So starting with number 18 and 19, we're going to be focusing on our vertical stretches and shrinks. And if we're going to write this out, and whenever I write this, I think of this as for a positive constant, so c greater than 0, c is positive. A constant times f of x will result in a vertical stretch or shrink. A vertical stretch or shrink. And we'll talk in a second about how to define whether it's a stretch or a shrink. So, if we start with y equals x squared, then we look at y equals 2x squared. So I'm going to plot these all side by side on my graphing calculator. And then y equals 1/2 x squared. So I'm graphing that as 0.5x squared. Same thing. If I look at my graph, so here's my parabola y equals x squared. Y equals 2x squared, this guy in red is skinnier, taller. And then this green guy is wider and flatter. So I want you guys to notice that skinnier or narrow and taller, those all go together, right? So taller and skinnier, those produce the same effect. Widest, flattest, shortest, those all produce the same effect. Alright, so here's our constant. Our constant is 2 multiplied by our x squared function. Here our constant is 1/2 multiplied by our x squared function. So vertically, just focusing on the y values, if I take a look at my table, I know I usually use trace, but I'm going to take a look at the table now. So second and graph to go into the table. Oops, I'm going to scoot over here. Alright, so starting with x equals 1 and x equals 2. So I'm looking at these two rows here. For my parabola, my regular y equals x squared, I have the ordered pairs 1, 1 and 2, 4. So 1, 1 and 2, 4. For y equals 2 times x squared, I have 1, 2 and 2, 8. Right? 1, 2 and 2, 8. So what happens is the x values are staying the same, right? 1, 2, 1, 2, 1, 2. We're not messing with the x values here because this is a vertical change, so we're only messing with y. For this transformation, 2x squared, I'm going to take whatever my original y values were and I'm going to multiply them by that constant 2. So 2 times 1 gives me 2 for my new y value. 2, my constant, times 4, my previous y value. So 2 times 4 is where that 8 comes from. So remember that f of x and y are the same things. For these vertical stretches or shrinks, I'm taking that constant and multiplying it by whatever my y value was. In this case, 2 times 1, 2 times 4. Over here, for y equals 1/2 x squared, or y equals 0.5x squared, now my constant is 1/2. So 1/2 times 1 gives me 0.5, or 1/2. 1/2 times 4 gives me 2. Right? And I can see 1 and 1/2, and then 2, 2. So the rule for these, because you're multiplying your y value by whatever that constant is, if the constant is big, like 2, so if it's greater than 1, if the constant is greater than 1, and all of these are going to be positive constants, so if the constant is also greater than 1, that's going to be a vertical stretch. If the constant is less than 1, and it's also greater than 0, so I can write that if you want me to. So if the constant is less than 1, a fraction like 1/2, multiplying numbers by 1/2, 1/4, 1/8, 2/3, that's going to shrink those numbers and make them smaller. So this would be a vertical shrink. So bigger numbers stretch, smaller numbers shrink for vertical. Okay, so looking at these without using a calculator for number 19, y equals 4 times the absolute value of x would be a vertical stretch. I know it's vertical because the constant is out in front of the function, and 4 is greater than 1, so I know I'm going to have a stretch. For b, y equals 1/4 times the absolute value of x. It's vertical because 1/4 is out in front of the absolute value sign. If it were inside with x, that'd be a different story. And 1/4 is of course positive, but it's less than 1, so that results in a shrink. Now our horizontal stretches or shrinks are a little bit trickier, and this is where a lot of students have trouble, just to warn you guys. So for our horizontal stretches or shrinks, again we're going to look at our y equals x squared function as our kind of baseline function. So now instead of 2x squared, I have in parentheses 2x close parentheses then squared. So now notice that that constant is inside the parentheses with the x. So it's multiplying by the x, not by the overall function. Down here, y equals, I'm going to put 0.5 x in parentheses squared. So notice that that constant is inside parentheses with the x rather than out in front of the original function like what we had back in number 18. Okay, so those parentheses connecting that constant to x, that's significant. Alright, so when we have a constant, and we're going to think of this as, so this is always for a constant that's greater than 0. When we have f of c times x, so in parentheses the constant is being multiplied by x, this is going to be a horizontal stretch or shrink. Now if we take a look at what's happening with all three of these, and it'll be a little trickier in our table, but we'll do our best. There's y equals x squared. This skinny red one, I have it in green on the page here, but this skinny red guy on my calculator, that's y equals 2x squared, so 2x in parentheses squared. So let's just focus on this, it's red here and it's green on my page, but this y equals parentheses 2x squared. So before we were talking about whether something got taller or shorter, right? Vertically if we stretch, taller or shorter. Now we're thinking about fatter or skinnier, wider or narrower. So comparing our original parabola to this red function or to this green function, this guy is the narrowest. The narrowest, which by the way is also the tallest, but horizontally we're shrinking in, we're getting skinnier, we're getting narrower. So y equals 2x in parentheses squared is a horizontal shrink by a factor of 2. This constant multiplied by x, the constant is greater than 1, that produces a shrink. This seems weird because back when we were looking at our vertical stretches or shrinks, if a constant was greater than 1, that was a stretch. Now for horizontal, if a constant is greater than 1, it's a shrink. So why is that? Well, remember our horizontals are always a little bit weird, and what's happening is instead of y times the constant like what we had before, now we're going to be taking x and dividing it by whatever that constant is. So if I take x and divide it by a big number like 2, those x values shrink down. So for example, so we're keeping the y's at 1, 4, 1, 4, 1, 4. Those aren't changing. And we're just changing our x's. We started with 1 and 2 as our two x values. If I take 1, my original x value, and divide it by 2, my constant, that gives me 0.5. If I take 2, my original x value, and divide it by 2, my constant, that gives me 1, my new x value. Over here, for my third function, y equals 1/2 x squared. Now 1/2 is my constant. My constant is less than 1. And remember, these are always positive constants. So if I have a constant that's greater than 1, that actually produces a horizontal shrink. If I have a constant that's less than 1, like 1/2, that actually produces a horizontal stretch. The reason is, if I take my original x values, 1 and 2, if I take 1 and divide it by 1/2, that actually equals 2, right? 1 divided by 1/2. 1 divided by 1/2 is the same thing as 1 times the reciprocal 2 over 1. 1 times 2 gives me 2. 2, my original x value, divided by 1/2, my constant, equals 4. 2 divided by 1/2 equals 2 times the reciprocal 2 over 1. 2 times 2 gives me 4. So my x's got bigger. Bigger x's make my graph wider or fatter. So that's a horizontal stretch. Alright, so for number 21, without using a calculator, determine the following. Y equals absolute value of 4x. Notice that the 4 is inside the absolute value sign, so I know it's going to be a horizontal stretch or shrink. Because horizontal is the weirdo, because I'm taking x and dividing it by the constant, if I take x and divide it by 4, my x is going to shrink. Y equals 1/4 x inside the absolute value sign. Because the 1/4 is inside next to our x, I know it's a horizontal stretch or shrink. And if I take all my x values and I divide them by 1/4, that's equivalent to multiplying all of my x values by 4, which will stretch them, make them bigger.